And I'm going to continue sharing my screen. There we go. Okay, so we have a number of topics that we want to cover today. So I'm going to start, first of all, by setting the scene and explaining a little bit what's the problem that we want to solve with Kedro. Then we're going to introduce Kedro itself and talk a little bit about what it is and how we came to create it and what's the current situation of the project. And then we're going to start straight away with the hands-on practical part. So we're going to see how to create your data catalog so that you can specify your data sets in a declarative way. We're also going to give some tips on how to refactor your code into a Python reusable library. And we're going to combine the modern Python packaging standards with how Kedro expects the files to be laid out on disk. Then we're going to create our first Kedro pipelines to do some very basic processing. And we're going to finish by visualizing this data flow with Kedro Viz. So first of all, before we start, allow me to introduce myself. So my name is Juan Luis. I'm an aerospace engineer originally, but I'm a self-taught Pythonista, and I've been working as a Python developer and trainer for many, many years. I love open source communities, and that's a big reason why I joined Quantum Black as developer advocate for Kedro. I'm very involved with the Python community in Spain. I originally created the Spanish branch, we could say, of the Python Software Foundations, the Python Spain nonprofit. And I've been organizing for the past year the PyData Madrid meetups. So I'm very passionate about connecting with people through open source communities and Python. And finally, I'm on my way to become a Kedro expert. So first of all, what's the problem that we want to solve? So imagine that you're building a house. So this house is going to be unstable unless you have a proper blueprint and a clear construction plan. And in a similar way, data science code behaves like that. So by applying software engineering principles to data science, it's going to improve our analysis and our models so that they're going to be much more reliable and much easier to maintain and understand in the future. Otherwise, you're going to have something like this. So you will have insights from your machine learning code, and maybe that's all you need, but it's not going to be built for the long term. And if you have to maintain this over time, then it's very likely that you will suffer a little bit. There are lots of challenges with creating machine learning products, as probably many of you already know. These are just some quotes that we have been collecting over the years from our users and clients. Things like everybody works in different ways. People spend too much time trying to understand the code base that someone else wrote for them. Difficulties in reproducibility because our code is not going to run in someone else's machine, and so on and so forth. But what if I told you that machine learning is not the hard part? Okay, don't get me wrong. Machine learning is hard. The point of this is to say that just doing the machine learning model, which is a ton of work in itself, is not the end of the story. That we need to present our insights, but also it's very likely that we will need to maintain this system over time, and that it's going to become a piece of the production infrastructure that we have in the company. And here's where Kedro joins the scene. I'm going to pause for a moment to see the questions that we have in the chat. So, okay. So far, so good. So first of all, Kedro is an open source Python framework created for machine learning and data practitioners. It tries to apply the 12-factor app philosophy that you might know from software engineering, became very popular with web frameworks some years ago. And in summary, it tries to apply principles of modularity, separation of concerns, versioning, and more. Why we created it? We often say at Quantum Black that we created Kedro out of scar tissue because of how we were developing and putting into production machine learning projects. So we were trying to address the shortcomings of Jupyter notebooks with a focus on having maintainable data science code. We're going to talk a lot about notebooks in a moment. And just to give you a sneak peek, we think that notebooks have their place. It's not our opinion that we have to abandon notebooks at all costs. So what we're trying to do with Kedro is to encourage good software engineering practices for parts of that code that instead of living in a Jupyter notebook can live in a Python library in a reusable Kedro project. So in general, you can think of Kedro as React or Django for machine learning projects. It has a number of recognitions and awards. It has won over the years, and it has more than 8,100 stars on GitHub. With your help, maybe a little bit more. So I'm going to stop here for a moment and ask you to drop in the chat where are you joining from and what's your current job title or role. For example, I'm joining from Madrid and I'm developer advocate. So don't be shy, just drop a message in the chat so I can see them coming. Pascal joining from Germany, data science, Elaine from Brazil, Edgar from Colombia, Ignacio from Spain, Pablo from Mexico, and many others. So we have lots of data scientists, lots of data analysts, some fellow aeronautical engineers as well. Hello, researchers, data scientists, and many more. Well, great to see some people joining from the past country as well. Excellent. Well, thank you very much all for chiming in. We're going to get to the practical part very soon, but I would like for it to be very interactive. So I'm going to keep an eye on the chat at all times. And whenever you have any question about what I'm explaining or anything else related to Kedro and so on, just feel free to drop it in the chat and I will do my best to answer. So this is the current Kedro logo that you will see in many places in our website and GitHub organization and so on. And I want to remark as well that Kedro is at the moment an incubation stage project of the Linux Foundation, the AI and data branch of it. So we donated Kedro to the Linux Foundation some years ago after open sourcing it, because we truly want Kedro to be a multi-stakeholder project that does not depend on a single entity. At the moment, the main entity developing Kedro is Quantum Black, a McKinsey company. But very recently, we have invited people from other companies, such as Getting Data in Poland, to join our technical steering committee. So we're making strides towards becoming a truly multi-stakeholder project. Kedro has a number of components that we're going to see very briefly. So on one hand, it gives you the project templates. It's inspired by the ideas of the cookie cutter data science that you might have seen elsewhere. And the idea is that whenever you're starting a new data science project, or even if you want to migrate an existing project to Kedro, you have a series of directories and a way of organizing the code so that you don't have to think about it. And every Kedro project is similar to other existing Kedro projects. So it minimizes friction and risk. On the other hand, it gives you a data catalog, and this is one of the key components. So the data catalog is a declarative layer that allows you to specify where are your data files or where are your data sources, whether they are files on disk or remote files. We're going to see some examples. And you will be able to store them separately from your code so that you can have a more abstract way of referring to those data sets without having to hard code any file paths and so on. Then Kedro gives you some plumbing to create nodes and pipelines. So every pipeline in Kedro is going to be made of Python functions, and then these Python functions are assembled using nodes. So whenever you want to do any data processing or data cleaning, or create some reporting pipeline that produces some artifacts, then Kedro will help you create these pipelines by using some CLI commands and assembling some Python functions. Finally, Kedro provides a whole ecosystem of plugins and extensions. You can extend Kedro by using the available hooks in the library, also by creating your own datasets. And in general, the idea is that you can make Kedro work for your specific use case. The way we see Kedro is something that is going to help you in all the stages of your data science and machine learning pipeline development process. But then we purposely want to stay away from pipeline orchestration. So you can use Kedro from the raw ingestion stage up to the model validation and reporting and so on. And then when you want to put a Kedro project into production, we usually encourage users to use a proper orchestrator, very similar to how you can run a Flask or a Django web application with the development server, and it's okay for some use cases. When you want to get serious and put things into production, Kedro can integrate with a number of orchestrators such as Airflow, Prefect, Argo, and many more. Here's a comparison of several other open source projects that are often compared to Kedro. This is not meant to be exhaustive, but just to give you an idea of the kind of things that you might find elsewhere. So, for example, Kedro can be compared to dbt, that has become very popular these days in the cloud data warehouse world. So dbt is primarily a SQL transformation workflow tool, although it also has support for Python these days. And then you have other systems like DDC, for example. There is version control for data so that you don't have to commit large data files to your version control systems. And Cookie Cutter gives a fraction of the functionality that Kedro offers, in this case, only the project template that is, in fact, one of the dependencies of Kedro. And there are other systems that overlap somehow with what Kedro offers, or can be used to complement its features. So, for example, the orchestrators that we were mentioning a moment ago. We're proud to say that Kedro is used in lots of different companies, big and small. Of course, we use it a lot in our own projects with clients at Quantum Black and McKinsey, but being an open source project, Kedro is used in many different places that are outside of our sphere of influence. You have some big actors like NASA, for example, and companies from very different backgrounds and industries. If you want to stay in touch with the Kedro community, there are several ways that you can do that. For example, we have a Slack workspace where we usually and do announcements and so on. And most importantly, where all our users come to ask for support. So we have a questions channel that is quite active. And it's not only us on the technical steering committee answering questions, but also all the people from the community is chiming in as well. So if you ever have any question about Kedro, be it a beginner one or some advanced use case that you're trying, I very much encourage you to join there. Our documentation is hosted on Twitter docs, so you can see that at docs.kedro.org. And finally, our source code in all our development process happens on GitHub. So if you want to get a sneak peek of what we're working on and what the current roadmap is in all our conversations and so on, feel free to go there. And of course, it also works for bug reports. And if you want to contribute code or documentation, you're more than welcome to do so. So up to this point, are there any questions or comments in the audience? Waiting for you for a moment to drop them in the chat. If not, we're going to jump straight to the practical part. It's workshop time, so I'm going to stop sharing this presentation, and I'm going to jump to the source code. So we're going to use this repository here that I'm going to share with you in the chat. And very quickly, I'm going to click open on Gitbot here, so everything starts happening in the background. And while this happens, and all the dependencies are installed and so on, I'm going to explain you a little bit the dataset that we used and what we're going to do. So the dataset that we're using comes from the Open Repair Alliance. So the Open Repair Alliance is a community of people that advocate for the right to repair. And in many different places across Europe and other continents, they host events, usually called repair cafes, but not only, where people can bring their appliances from home and have a volunteer try to repair that. Sometimes it's going to be a vacuum machine or a lamp or things like that. And these people are very systematic, and they've been recording for many years every single attempt of repairing some device, and where did it happen, and what was the reason why the device was brought, and so on, and whether the repair could be performed successfully or not. So we have not so big data sets. We have a little bit over 80,000 rows. So it's not going to be big data by all means, but it's going to be a good example of how can we apply some of these concepts to a real world data sets. So if you want to follow along in the repository that I shared, you can click the Open in Gitpod button yourselves, and you can try and see the results for yourself. On the other hand, in the workshop steps branch, you will see that each of the commits contains part of the progress towards the solution that we're going to show in the end. So if at any point we're stuck or we're not sure how to continue and so on, we already have the cheat sheet over here. And as you can see, each of the steps that we're going to follow is described in the README as well. I'm going to show now that all the data was downloaded for us, so we don't need to do anything. And then we can start refactoring our data loading using the catalog and so on. So hopefully the instructions that are written in the README are going to be hopefully clear enough for you if you want to follow along. So without further ado, I'm going to come here, and my Gitpod environment is ready, and my Jupyter Lab notebook is as well. So just to avoid having you make a leap of faith for me, let me explain very briefly what's going on. So this Gitbot interface, in case you haven't seen it, is what we call a remote development environment. In this case, based on VS Code and on the open source parts of it. And we created some bootstrapping code over here so that we're using Python 3.10, which is the latest version supported by Kedro. And also downloading the data so we don't have to do it ourselves, launching Jupyter Lab, installing some of the dependencies, and so on. So when you click the Gitbot button and everything is ready, then you will have two terminals, one corresponding to Jupyter Lab, which is the service that I just opened in another tab, and another one over here that you can use for launching Kedro and anything you need. So I'm going to check that, that Kedro is installed over here, which apparently isn't. Yes, sorry, because we're going to launch Kedro later on, but we have Python 3.10 installed here. And then from that remote development environment, I'm launching Jupyter Lab so that you can see this exploratory data analysis that I did of these data sets in a notebook format. So as I mentioned, we're using the open repair data, and this data contains two main CSV files, one corresponding to the repair events themselves, so what device was repaired and so on. We're going to see what is contained there in a moment. And another one containing the product categories. So there's some redundant and inconsistent information in these two data sets. And we're going to do some very simple data cleaning and data preparation that then we're going to move to a Kedro pipeline. So without further ado, let's get started. I'm going to use the Polars library for all the data processing. So in case you don't know it, Polars is an alternative to Pandas that has become very popular in recent months. That it's also based on Arrow in a similar way as the new Pandas 2.0 version is. But it uses the Rust implementation of Arrow, and it focuses a lot on efficiency and speed. We're not going to notice that with this modest data set that we're going to use. But what we are going to see is that the API is a little bit different from Pandas, and it's very similar to how we're used to work with Spark, for example. So we're going to see that it's going to be a mix of the two. So what I'm going to do first is loading the data with the polars.read CSV. This one is very similar to Pandas. I need to specify the D types of two of the columns. So the product age and the group identifier, I have to tell Boris that they are a float and a string respectively. And then I'm going to instruct the library to try to parse the dates as well so that we can manipulate the dates more easily. And if I run this, then I end up with a data frame view here, pretty similar to what we would get with Pandas. And let's have a look at this data set. So we have an ID column that we're not going to look at much. We have a data provider, which is what specific community or group of people contributed this section of the data sets. In what country did the event take place? Then what's the product category? You're going to see that there's a mix of languages in these data sets. So later on, we will be focusing only on the English part. And then we have the product category ID. This is what I told you that it's redundant with the other CSV. what's the brand, that sometimes it's unknown, year, the age of the product, whether the product was repairable or not, and then some columns that tell us what happened originally with the product and whether it could be repaired, or if the product was end of life, and if so, what happened to it. So we have these 14 columns here. We see that we have a little bit over 81,000 records. And what we're going to do next is loading the categories CSV into another Polars data frame. So you see that some of the methods are similar to pandas. For example, we have head and so on. But then if we want to combine these two, we need to depart a little bit from what we're used to in pandas. So what I'm going to do here, and I'm going to spell it out so it's a little bit easier to see. I'm going to call the select method of the first data frame, the main one. And I'm going to tell it that I want all the columns except from the product category 1. And then you can see that I don't have the product category anywhere. And I'm going to join this with the other CSV file that contains the product category ID and the product category. I'm doing this so that I trust that the categories CSV is my single source of truth, and I don't need to reconcile the categories or decide which one is correct and so on. Notice though, and this is an interesting feature of Polars, that the expression that I'm passing to the select method can be computed externally. So this is a standalone Python object that makes sense on its own. And this is what makes Polars so interesting. But enough about Polars. Let's continue with our processing. So I'm going to comment these two out. And you see that I'm taking the output of that selection, and then I'm joining that with the categories on the product category ID. So here I have my combined data sets. I still have 81,000 rows. And now let's do a little bit of exploratory analysis. So for example, I might want to know how many events existed per country. So in that case, I'm going to pick the country column, compute the value counts, and then sort that by counts. And as we can see, the majority of the events happened in Great Britain. And then we also have events in the Netherlands, Germany, Belgium, and Denmark. I might also want to see what are the available product categories. And I'm going to do another value counts followed by a sort. And you see here that most of the devices that were brought were lamps, vacuums, laptops, but we have plenty of other things. And then one thing that is happening with the repair barrier is that there's an inconsistency in the standard. So if we display what are the existing values, you see that in many cases it's not filled. This means that either the repair barrier was not known or that the product could be repaired in the end, and so there was no point in filling this column. But then we have product to worn out and item to worn out. So upon reading the standard that you can check for yourselves, I'm sharing with you the link over there, you will see that it's actually the same category. So product and item here can be used as synonyms. And what we're going to do is to replace one by the other so that our numbers are not distorted. So as you can see, this is a very mild and easy exercise of data quality, but it's hopefully going to be a showcase of the kind of things that we can do. So what I'm going to do here is I'm going to take the repair barrier if end of life column, And I'm going to map the values that are item to earn out and replace them by product to earn out. And if these values are not, sorry, if this is not the value that that the row has, then by default it will have whatever is in the column. So I'm using that as an input to with columns, and as a result, I'm going to perform a replacement of all the values. So as you can see now, product to earn out is the only column that contains the addition of the other two. This 200 plus 500 give me roughly 747. Okay, so that is it for our exploratory data analysis. And now that we have this notebook, it's a moment to ask ourselves whether we want to continue adding business logic here and adding visualizations and so on, or if we want to take the opportunity to refactor this a little bit into a maintainable Kedro project. And that's what we're going to do now. So I'm going to stop now for a second, and I'm going to have a look at the chat. Are there any questions or comments so far about what we saw? Nobody asked me what's happening with my autocomplete. I'm very disappointed to see that. But just mind you that I'm using an extension called Jupyter LSP that turns Jupyter Lab into more of an IDE by adding some more advanced autocomplete functions and the ability to jump to the function definitions and so on. So I'm going to share this just in case. All right. So if there are no more questions or comments, then I'm going to proceed with Kedro. So the way we usually teach Kedro is by creating a new project with some of the starters. So we have the default starter that contains the raw project template and nothing else. And then we have other starters that help you develop Kedro projects with some specific functionality in mind. For example, because they are Spark dependencies or something like that. So I'm going to share that with you, Kedro starters, just in case. But the way we're going to do it now, it's a little bit different. So we're going to be building the Kedro project from scratch so that we understand at every step what Kedro wants from us and what are the things that we want. So Juan Pablo asks, what was the purpose of the add-on? So do you mean the Jupyter LSP? If that's the case, Jupyter LSP gives me some more advanced autocomplete. So for example, if I hover with the mouse here, you see that there's a box appearing with the documentation of the function and so on. Makes the experience of working with Jupyter Lab a little bit more enjoyable. Okay, so we're going to start now. And for now, I'm going to go to the README and actually going to show that in VS Code so I can see a rendered version of that. And we're just going to follow the instructions. So the first thing is, since we're going to start using the Kedro catalog, we're going to add Kedro as our dependency in our requirements.txt, and we're going to install it. So let's get started. I'm going to open my requirements.txt that already contains some of the dependencies that I'm using just to launch the Jupyter notebook that you saw. And I'm going to add here Kedro. I'm going to use 0.18.7. The absolute greatest of Kedro is 0.18.8 that was released yesterday. So we're going to depart a little bit from the instructions in the workshop and use the latest version. There's nothing breaking in it, and just a bug fix release. So now I'm going to proceed and install it. So I'm going to pip install -r requirements.txt. And as you can see, Kedro and its dependencies get installed. So after that is done, I'm going to verify that Kedro info works. So let's see. There we go. So now we have Kedro 0.18.8 and everything is ready. Then we're going to need a bleeding edge version of Kedro datasets. So Kedro datasets is about to see another release, but we want to use some of the Polars datasets that were recently merged to the main branch. So we're going to just copy paste this to the requirements.txt. This requires the normal specification, as you can see, so Kedro dataset with both the pandas CSV dataset and the polars CSV dataset. And then I'm specifying the URL. So I'm installing from a specific commit of the Kedro plugins repository. So I'm going to repeat again, do a pip install requirements. It's going to clone Kedro plugins and then install it along with the dependencies. And now we're going to start shuffling our data around and gradually approaching what in the end will be the Kedro project template. So I'm going to create a directory inside data. It's called 01 raw. This follows the usual data engineering convention that we use in Kedro. And then I'm going to move all of these files over here to that directory. So now everything is under data 01 raw, including the README of the dataset itself. You can see if you do data 01 raw, you can see it there. And now let me continue reading the instructions so we don't get lost. And what we're going to do now is create our data catalog. So the data catalog in Kedro lives in a directory called conf/base. There's a conf/local that Kedro expects as well. So I'm going to create that now. And these two directories serve different purposes. So the base configuration is, so to speak, the main configuration that we're going to use. And then local can be used for things that are only applicable for our local development environment. We're not going to touch that, but the directory needs to exist anyway. And then inside base, I'm going to create my catalog.yml. And here I'm going to start dumping my datasets. So a dataset in Kedro is a specification of what's the source of the data and what additional parameters I need to read it, along with the type of the dataset. So I'm going to call my dataset OpenRepair03 just because it's the version of the dataset that the Open Repair Alliance gives. Events raw. So this is going to be my first dataset, and the type of it is going to be polars.csv dataset. My file path will be data/01 raw, and then the name of the CSV, which is going to be aggregate CSV, etc. This one here. And then, if you remember, if I go back to the Jupyter notebook for a moment, the read CSV function call in Polars required some extra parameters. So I'm specifying what are the data types, and I'm also telling it to try to parse the dates. So I'm going to specify both here. So the load args will be the D types. I will leave this blank for a moment. I will need to explain one thing. And then try parse dates is going to be true. What happens with the D types? As you can see, this is a YAML file, but Polars asks for Python objects here to specify the data types. So I need some magic for this to work. And what I'm going to do is I'm going to define some template variables that then will be specified somewhere else in the code so that I can pass these Python objects easily to the catalog. Let me stop with the chat for a moment. Pablo says, which data structures are supported by Kedro apart from Polars data frames? And the answer is many of them. So if you go to the Kedro documentation and you scroll down to the Kedro datasets part that I'm going to share with you here. Kedro datasets is a separate package that contains a number of third-party datasets that we are maintaining officially from the Kedro team. So you can see things, for example, like a Parquet dataset, GeoJSON, HoloViews Writer in case you want to dump some plots. We're going to see an example with Matplotlib that is also here. JSON, Excel files, HDF files. What else? TensorFlow models, video datasets, YAML datasets, and so on. So this is just a sample of what you can do, but people can define their own datasets. For example, I'm currently working on my own Kaggle dataset. It's still in progress, but it's definitely something that you can do. And all the instructions to create your own datasets can be found in the documentation as well. Then Rafaela, I think you directed this to me, so other people cannot see it. If you want to pose the question again, but I'm going to read it out loud anyway. So can you create another conf environment besides base and local? If so, how do you change which configuration Kedro is using? And the answer is yes. You can have several environments here. Let me see if I can locate that part of the documentation quickly. Configuration environments, there we go. So by default, Kedro has base and local, but if we want to define our own environments, let me see how to specify additional environments. There we go. Then the way to use that is by having the corresponding directory under conf. So for example, conf/test like this. And then when you do Kedro run or use any of the Kedro commands in the CLI, then you will need to specify what environment are you using. And this applies as well to local. So the answer is that you just need to create a separate directory, and then you will need to specify it on the CLI anyway. So I'm also going to share this documentation with you. Thank you very much for the questions, everyone. Keep them coming. So we're going to continue defining our dataset here. And I was saying that I will need to pass some Python objects here, but this is a YAML file, so I will need to do some magic. So what I'm going to do is I'm going to specify the product age as a template variable like this, and that I'm going to call PL_float64. I'm going to show later how this is filled. And then group identifier, it's going to be a similar thing. So PL_UTF-8. So this is the definition of my dataset. Now, back to my Jupyter notebook, I will need the first time to manually instantiate the Kedro catalog. This is not necessary when we're using the full Kedro project template, but if you want to just use the catalog of Kedro, you can absolutely do that, but you need a little bit of boilerplate. So what we're going to do is we're going to import from kedro.config import the templated config loader. I could have used the default config loader, but since I want to do this trick with the variables, I'm going to use that. And then from kedro.io import data catalog. So that's the first thing. Then I will need to load my configuration and here configuration includes the catalog, but will include other things. So I'm going to use the templated config loader on the conf directory, and I'm also going to pass some variables here. So I'm going to pass a globals dect that is going to contain some template variables that I'm going to define just here. And these template variables are going to be PL float 64, so the one that I was using before, and this is that. And then PL UTF-8 is going to be that. And this is going to end up in a variable called conf loader that you can display here if you want. And then with this conf loader, I'm going to instantiate the catalog. So if I get catalog.yml, this is my catalog. And as you can see, this is just loading the YAML file while applying my template variables here. So I see that the dtypes have this product age, and this is a polars object. But this is a representation of the catalog. This is not actually an object that I can use. So what I'm going to do here is now instantiate the data catalog from config, and I'm going to pass that catalog. In fact, I'm going to call this catalog conf. I'm going to rename that to catalog conf. There we go. And then this will be my actual catalog here. So the catalog does not have a fancy representation. Whoops, I need to rerun the cell. The catalog doesn't have a fancy representation, but what the catalog gives me is a load method where I can pass now finally the name of my dataset, that if you remember was open repair 03, let me get the name right, 0_3 events raw. And if I do this, observe that I get exactly the same polars data frame that I was getting before. So if you ignore the boilerplate that we had to write in the first place, now this cell gives me a way to decouple how am I loading the data and where exactly the data lives from the actual code in the Jupyter notebook. So if the data tomorrow goes to another directory, or if I need to add more parameters and so on, I don't need to touch the notebook at all, because I already have that defined in the catalog. So I'm going to do df equals that, then df.head, and I'm going to delete this cell because I don't need that anymore. And as you can see, the length is exactly the same. Javier says, how useful? Thank you very much. Danilo asks, is there a future plan to have a polars Parquet dataset? Yes, indeed. And we have in the Kedro plugins, we have a pull request for a polars generic dataset. And this in principle should allow us to load, sorry, this was rebooted somewhere else. So it's this pull request here. No, sorry. Polars generic, there we go. This pull request here. So the idea is that we will be able to load any file type compatible with polars from Kedro. It needs a little bit of work from our side, but it's definitely on the radar. So yeah, good question. Okay, so I'm going to wrap up this first section by defining the other dataset that I need. So if you remember, I also have this categories.csv. I'm going to go ahead and define that as well. So I'm going to add a dataset called open repair categories. And then the type of that is also going to be polar CSV dataset. The file path is going to be data 01 raw, but then it's going to be 03 product categories.csv. And if you see, in this case, the read CSV does not need any extra parameters, so I don't need anything else. What I do need is to reload the catalog. So I'm going to run this cell again and recreate the catalog. This still works, but now what I can do is doing catalog.load and then open repair 03 categories. And as you can see, I get, again, the same data frame as before. So I'm going to save that as categories, show the head of it, and I'm going to remove that cell because I don't need that anymore. Okay, so now I have my catalog and I have successfully started using Kedro for my project. And I could stop here. Like there's nothing forcing me to use all the other parts of Kedro. Of course, there's lots of advantages that I hope I can convince you from trying. But if you're just interested in the Kedro catalog, then you could as well stop here. So it's a good moment to commit our work. I'm going to switch to a new branch, workshop. Sorry, that was supposed to be 05. And I'm going to add git status. I'm going to add the current status of my Open Repair notebook, not before clearing up all the cells so that I don't have conflicts with the outputs and so on. So I'm going to add the notebook here, and you will see that I have my catalog definition and so on. So I'm going to just add everything. And I'm also going to add whatever is in my conf directory. And I'm going to add my requirements as well. So commit, use Kedro catalog. There we go. Paulo asks, can we include additional polars or any other library flags in our config file, such as infer schema? Or is the schema required to be strongly typed? The schema is not required to be strongly typed at all. It's an artifact of how this dataset works. So, for example, if I try to do pl read CSV with this particular dataset, so now data 01, and then open repair, aggregate CSV, and I don't put anything else, then I get a compute error. This is a typical thing. So it could not parse some of the columns because it was not inferring the types correctly. So that's the reason why I need to specify the schema. But as you could see, I'm only doing that with 2 of the columns because all the other ones could be inferred properly. So the answer is no, the schema doesn't have to be strongly typed, only if you need that. And then any other flags that you need to pass to read CSV, you can include those in the dataset as well. Okay, so now it's time for the second step, which it touches one of my favorite topics, which is Python packaging and libraries. So we're going to start getting serious now, and we're going to create a Python reusable library with its project metadata and so on. And in a moment, this library is going to evolve into a Kedro project. So let's start by installing Fleet. So Fleet is a tool that we're only going to use to create the project metadata very easily. And here you can use any workflow tool that you like. You can use Hatch, PDM, or some of the newer tools that have been created recently. So I'm going to do Fleet init. And this is going to ask me for a module name. I'm going to call it Open Repair. The author is myself. Whoops. It's not accepting my special characters. Anyway, my email is as follows. Let's see. The homepage is blank. The license is blank. And thanks to this, now I have my pyproject.toml. So for those of you that have never seen this file, it's the modern replacement of setup.py. And so it allows us to specify our metadata in a static way. And now we need to create a little bit of boilerplate for this to work. So all my library code is going to live under src/openrepair. So I'm going to write that. And inside src/openrepair, I'm going to create an init under init.py that contains a doc string. So openrepair data analysis and a version string. This is mandatory by flips. I'm going to call this 0.1.0 and that's it. So if I didn't do anything wrong, now I can pip install dot. So let's see if that works. And apparently, yes. So you see, by just creating this pyproject.toml file and a proper init.py, now pip understands that this directory is a Python library. So all the usual workflows that I use for library development are going to work from now. Let's uninstall this for a moment because I want to install it in editable mode, which means that any change that I make here to the code is going to be reflected in the installation immediately. And then I'm going to add some Kedro configuration to pyproject.toml. So in pyproject.toml, you can configure other tools that are not pip. For example, you might know that you can configure mypy or isort and things like that. So just as any other tool, I'm going to configure Kedro. And this requires me to repeat the package name, is openrepair, the project name, also openrepair, and what was the Kedro version that I used to create this package, in my case, 0.18.8. I would like to insist that most of this boilerplate is taken care of for you if you use some of the starters, but here we decided to do the exercise of creating everything from scratch. And so that's why I'm writing everything. Also to show that it's not that complicated. Then if I write Kedro help on the CLI, then you see that there are some project-specific commands here, like Kedro lint, Kedro run, Kedro test, and so on. And some of these are in the process of being deprecated, but in any case, it gives me a good indicator that I'm on the right path. Now, I'm going to move the boilerplate that I created on the notebook to load the catalog into Kedro. I don't need to write all of that because many parts are automatic, but some of them I do. So I need to create a settings.py file that then will contain the config loader that I'm going to use, in my case, the templated config loader. I'm going to need polars as well. And then I need to define a couple of global variables here. So one is config loader class, which is the templated config loader. And the other one is config loader args. And this one is whatever is going to be passed to the config loader. And here you see I'm going to paste the templated variables directly. And that's it. To add my trailing commas here. And the effect of creating this settings.py and this directory structure that is needed for a Python library anyway is that now I can remove this, and that. And instead, I'm going to restart the kernel to see that there's no magic. And I'm going to load an extension called kedro.ipython. And if I didn't make any mistake, then I should get no error messages. And the interesting thing is that now I have a catalog variable. So you see all the boilerplate was taken care of. And now I can use the catalog exactly in the same way that I was doing before. So I can load the data set. This still has 81,000 rows. And I can still load the categories, and all the rest is the same. Okay, so this was pretty cool. So I reduced the amount of boilerplate that I have to put in the notebook, which is always nice. And now the catalog appears magically here, which helps when I'm doing quick interactive work. And on the other hand, I have all the library boilerplate that I need to start using more of Kedro. In our case, we're going to see how pipelines are defined from now. So that's it for phase number 2. And I'm going to have a look at the chat for questions again. So far, how is it going? It's been 1 hour of me talking. So I hope that you're doing well. You can grab a glass of water if you want. Okay, so there are no more questions then. I'm going to continue by defining the pipelines. So let me go back here. And again, I have all the instructions that I need here, so I'm just going to follow. Now, why do I want to define some pipelines? Well, the reason is that I have all this code in the notebook that you see there's this join of the data frames, and then I was doing like some exploratory analysis just to see the cardinality of the variables and so on. And then I realized that I had to do some data cleaning, and I put that into df. So actually, after this cell that I have over here is where the proper data science work starts, right? And so all of the above could be considered data processing, data cleaning, whatever you want to call it. And then I would use the result of that to iterate. So my intention is to move all this code that I'm going to need to repeat every single time that I load this data set into a Kedro pipeline. And this Kedro pipeline is going to take care of automatically applying all these processing steps and producing a new CSV file that I will be able to persist to disk. And so that whenever I want to do any processing on it, I can just load the clean dataset directly without having to repeat the processing, right? So let's do just that. So Kedro has a number of CLI utilities that help me create these pipelines. In this case, I'm not going to write all the files from scratch because I don't need to do that anymore. So now I'm going to do Kedro pipeline create data processing. So my first pipeline is going to be called data processing, and you're going to observe here on the left and on the command line logs that there are some files appearing here. So now, still inside SRC, right? We have a new pipelines package. And this pipelines package contains one subpackage called data processing. And then my subpackage contains an init.py, some nodes, and some pipeline definition. We're going to see what each of these mean in a moment. And in parallel, this helper also created a blueprint for tests There are no actual tests in here, so it's my job to define them. I might want to use just normal PyTest, or maybe couple it with hypotheses or Pandera or great expectations or anything else that you want to use for testing your nodes. But I'm going to leave this blank for a moment. And I'm going to focus on the actual nodes. So let me open my README again. And I forgot to commit my code, so let's do that. Now I have my project.toml, I have my src, open repair. I actually created only the init.py, so I'm going to commit only that. And then I have, yeah, that's it. So let me just verify. There we go. So I'm going to commit that and say create Python library. So that would be my phase 2. For some reason, I'm not previewing the README. It's very annoying because it was working just fine a moment ago. So anyway, I'm going to read that from here. Turn the code into a Python library. We already did that. Create a data processing pipeline. So now we're going to start writing the Python functions that are going to take care of the processing in the nodes.py module. So my nodes are going to be normal Python functions that will take data frames as inputs and will return data frames as outputs. And in fact, whether these are Polar's data frames or not depends on how we connect those to the catalog. We're going to see what that means in a moment. So let's do a first function that joins the events. So I have it here, but I'm going to type it anyway. So I have my join events categories. And this takes events, which is going to be a Polar's data frame. Let me import Polars here so I can start using the types as PL. And it will also receive the categories. So the categories is going to be a Polar's data frame as well. And this is going to return another Polar's data frame. You don't need to specify the types like this, but it helps me show you what is going on. So my df clean is going to be the result of the joining operation that I was doing here. So you see, this is the df and the selection of the columns and then join on the categories. So I'm going to rename this to events. The other one is called categories already. So I don't need to do anything else. I'm going to return df clean. So that is my first node. And then the second node is going to be consolidating the repair barriers. So remember what was happening here with columns and so on. And again, the consolidate repair barriers, I'm going to just call it barriers for short, receives df clean. The names of the variables here are not important. And just calling it df clean for consistency with the output of the other thing. And this will also return a Polar's data frame. And then the final df is going to be the result of that. So as you can see, I'm just copy pasting from my notebook to my nodes. So I'm going to rename this as df clean. And the rest looks good. So now I'm going to return df. And that's it. Okay, so now I have my two functions here. And these are normal Python functions that you could use anywhere else in your processing. These are not tied to Kedro in any way. So you could as well start using them in the notebook and so on. But I'm going to jump straight to the pipeline definition. So I'm going to go now to pipeline. And then there's a little bit of a boilerplate that was created for me, but I need a bit more. So I will need to import my two nodes, which are join events categories and consolidate barriers. Now, how do I define a pipeline? So the pipeline definition needs to be inside this create pipeline function, which has to return a pipeline. And then a pipeline is a list of nodes where every node is a wrapper around each of the Python functions. So you see I have the node constructor here, and this is going to have one node and another node. Because the pipeline is going to be two steps. One, joining the events, and this requires two inputs. And the next one, consolidating the barriers. And this will also produce one output. Thank you very much, Gift. Many years simplifying things. All right, so this node receives a series of parameters. So on one hand, I need what function do I need to use? So this is the join events categories function. Then I need to tell it what are the inputs. And this is the key part, because these inputs are going to be references to my catalog. Therefore, I need to go here and say, okay, I need to merge this dataset and this one. So this is going to be open repair 03 events raw and open repair 03 categories. Next, I'm going to tell what the outputs are, and I need to give a name of the data set that is going to be the output of this node. And this is important. So far, I haven't defined more data sets in here, and you're going to see what's the effect of that. But for now, I'm going to call that open repair 03 combined. Again, this is a data set that so far doesn't exist, but we will get there. And then finally, I need to give this node a name. So join events, and I usually use the name of the function, categories underscore node, and that's it. That was the first node, and then the second node is exactly the same. So this is function is consolidate barriers. Now the inputs are, what are the inputs of this? The outputs of the previous node. So this will be open repair 03 combined. Then the outputs, again, this is going to become a data set, but one that I didn't define yet. And since this is the end of my data processing pipeline, I'm going to call that open repair 03, and that's it. And this would be like my final result. And then the name is going to be consolidate barriers. That's it. Okay. So this is my pipeline. It has two nodes, one after another. The fact that I'm using the output of the first as input of the second is not mandatory. You could have disconnected pipeline somehow, or I can arrange this in any way I want, but usually I will want this connection to happen, because otherwise Kedro is going to decide the order of the execution for me. There's one more bit of boilerplate that we need. We need to create a module next to init.py and settings called pipeline registry.py. This is a Kedro thing. And I'm going to just copy paste this because this is pure boilerplate. So the idea here is that I'm adding some logic so that Kedro can discover where the pipelines are. And essentially it's going to scan all the sub packages in search of other pipelines. So I'm going to just leave that there. And it's a moment to see if I'm doing things right. So I'm going to run Kedro registry list. And you see that there are two pipelines appearing, one called default and another one called data processing. So in this case, default is actually data processing because I don't have anything else. So there's always going to be a default pipeline to run. And now what I can do is to try and actually run this pipeline. So if I do Kedro run, you see there's a bunch of output coming, and let's see what's going on here. So Kedro is loading the data from this data set. It's also loading the other one. It's running the first node, so join events, categories, and so on. And it's saving the data to something called a memory dataset. And a memory dataset is here because that's the default dataset for Kedro, and it means that it's not being actually serialized to disk, it's being passed around in run. So that was the first one of the two tasks. Then the other node, sorry, the other dataset was loaded, the one that was just produced. It's running the second node, and it's producing another dataset, again, a memory dataset, and that's it. The pipeline execution has completed, and there's nothing else to do. So this is good because it means that things worked, but I didn't do anything useful, right? Because I'm not saving that data anywhere. I could find ways to use the result of that from the notebook and so on. But what I'm going to do is I'm going to define the data set in the catalog so that it gets actually persisted. So I'm going to now go back to my catalog, which is right here. And I need to define an open repair -03. And if you think about it, this has to be consistent with the output of the second node. And since the output of the second node is a Polars data frame, makes sense that on disk, this is a Polars CSV dataset. The file path for it, I have to make it up. But what I'm going to do is creating a new directory inside data. I'm going to call 03 processed or clean. And then this should be data/03 clean. And then I'm going to call this open repair.csv. This path does not exist. If I ls data, you see that it doesn't exist. But when I run the pipeline again, you see that it was automatically created. So now the pipeline runs, the intermediate data set, that is this combined data set, was kept in memory. It was not serialized anywhere. And then the last one, so the end of the pipeline, is this CSV data set. And this one actually got serialized to disk. And the result of that is that I can go back to my notebook. And if you think about it, I don't need any of this because I can say directly that df is catalog.load. We need to restart everything first, right? So let me restart that, then import Polars and the Kedro extension. And then this is going to be open repair 0_3. Whoops, I'm missing something. What's the error here? Aha. That the schema could not be properly inferred. This makes a lot of sense because this is the result of the previous, the original data frame being merged with the other one. So essentially, I need to use the same load arguments, you see? So it was properly saved, but then when I went to load it, it was failing because the structure is the same. So I need to add that information over there. I'm going to restart everything once more. And then if I didn't make any mistake, there we go. Now I have my DF. And so here we are. So now we have our Jupyter notebook. I'm still able to do anything I want here. So I can do any exploratory data analysis that I want, visualization. I can start training a machine learning model and whatnot. But now my notebook is almost clean of boilerplate. So I'm just importing polars because I'm going to need it later. But as you can see, I'm not even actually using it yet. I'm loading the Kedro.ipython extension so that I can use the catalog. And I'm leveraging the fact that this dataset is already defined and existing on disk so that I can load that directly without having to perform any of the data processing in the notebook. So I'm going to call this a success. I'm going to stop for a moment for questions. So Javier Blanco sending sunglasses emoji. Thank you very much. How are you doing so far? Questions, comments? Chris says, I have a data pipeline that needs to work for multiple data sources, and each source requires unique steps, followed by steps common to all data sources. Any thoughts on how Kedro could be of use here? So if I understand correctly, you have a data pipeline. Oh, wait a second. So each source requires unique steps, followed by steps common to all data sources. So the way I say it is that you actually have several pipelines. So you see the beginning of the pipeline is going to depend on each source. So you will have these specific steps that are depending on each particular data source. And then at some point, all of that is going to be consolidated. And then there will be some steps that are common to all data sources. And there are several things that can help you here. So on one hand, there's a way to reduce the amount of redundancy that exists in the catalog by using more advanced configuration loaders. For example, we have our Omega config loader. We have the advanced configuration documentation here. And there are a series of common use cases that we consider. For example, how to do templating with Omega config loader and so on. And as you can see, there are segments of the configuration that can be repeated on several data sets at the same time. And by virtue of variable interpolation, you could achieve that. So that is one thing. And then another thing, if you want to reuse parts of a pipeline, then most likely you want something called modular pipelines. So this is very typical when the complexity of the project grows. And the idea is that you have more advanced functionalities here by leveraging some of the more specific Kedro functionalities. So I'm going to share this documentation with you again. And the idea here is that you will be able to use these templates as some sort of blueprint that you can use for different data sets. So I hope that answers the question. It's a little bit of intermediate Kedro, but nevertheless is something that our users are very used to doing. So it's definitely something that is well supported. Ignacio says, if the start of the pipelines are SQL queries to some data source, for example, Athena, instead of files, does the query results be saved into a file and then I can start to use Kedro or can Kedro work somehow also with SQL queries as part of the pipeline? So I think there are several ways to answer this question. On one hand, pandas and polars do have some functionality to allow SQL queries that perform a select operation on some data source and then return a data frame, right? So that would be one of the ways that I would try that. And then for direct SQL support on Kedro, I actually don't know what's the status of that. Let's do a very quick search on the issue tracker of Kedro and Kedro plugins. So let us see.
I can actually help with this one a little bit.
Oh, okay.
I'm the product director on Kedro. So we do actually support SQL in a few ways. All of it's in Kedro datasets, actually. So we do have like a pandas SQL dataset that allows you to obviously pass your query. No, two actually, SQL data set and a SQL query dataset as well, which allows you to pass your input as this. Additionally, we just accepted contribution for a Snowflake one as well, which is using Snowpark. So maybe that's the way to get around it. But what we do say for this one is like, if you're exclusively working in SQL, it's actually just better to use something like dbt because Kedro is Python based, right? So it doesn't quite make sense if you're going to be switching in between, run all the stuff that you can possibly in SQL and then pick up from there and use Kedro.
Thank you very much, Yetunde. I didn't do a round of introductions when I started, but Yetunde is the product director of Kedro, part of the Kedro team as well. So she knows everything about the library. Okay, so Rafaela says, if my code generates a huge number of data sets that I need to serialize, do I need to manually add all of them to catalog.yaml, or is there a way to add more catalog entries from code? So this is a key question that has been part of our conversations for since I joined the company, basically, 3 months ago. So there's a couple of ways around that. So to some extent, you can use templating to, as I was saying, try to reduce the amount of repetition that you need on your catalog. And we're actively looking into other ways to do that. For example, there's an issue saying entries in the catalog. Yeah, I'm going to find it. But in any case, thank you very much. 2510. Yes, so our colleague Meryl is working on something called dataset factories that came as part of our discussion precisely to eliminate the need of having all datasets defined in the catalog. So addressing your exact questions. So the answer is that we have a more or less good answer for now, but very soon we're going to have a much better way of dealing with large catalogs like the ones that appear in really, really big projects. Thank you very much, Nok. And Nok is part of the engineering team as well. Okay, any more questions or comments? If not, I'm going to jump straight to the last part of the workshop. Yes, Danilo has one more thing. So Danilo asks, could you give us some insights on how to orchestrate large-scale pipelines on Airflow, Kubeflow, and so on? So good practices on how to trigger the pipelines, pass input and params to the pipelines, store the outputs, and notify that execution has finished. So you do have some documentation on how to integrate Kedro with some of the orchestrators. For example, in the deployment choices here, you have some documentation on how to deploy this with Airflow. And you have some information here, in this case using Astronomer, but could be a self-hosted Airflow as well. And you have other examples like Prefect, Argo workflows, Kubeflow workflows, and so on. For those of you that want like a way to decide what orchestrator or what deployment tooling to use, we have like a decision tree here that might help you. And then about specific good practices and so on that are not covered in the documentation, I very much encourage you to have a look at some of our plugins that we've been creating lately. For example, if we go to the GitHub of Getting Data, you will see that they have specialized a lot in deploying Kedro, and they created a bunch of plugins that you can use for that. So I definitely have a look at this. Marcin from Getting Data has recently joined our technical steering committee, and so they will be super happy to answer any questions you might have about this. But yeah, excellent question. All right, so thank you very much, everyone, for keeping it lively. We're going to go for the last part here, which is visualizing this workflow with Kedro Viz. So Kedro Viz is probably one of the most impressive parts of the ecosystem. I fell in love with it when I saw the interface for the first time. And I'm going to show you very quickly how you can leverage that to visualize your pipelines. Before that, I'm going to commit my work because it's a good time to do so. So you see that before that, I was creating my settings.py that actually belongs to the previous steps. I'm going to just amend my previous commits. And now what I did was adding my open repair pipelines like that, the pipeline registry that I will also need, and I'm going to commit the tests as well as the parameters that were created for the pipeline itself. So I think that is it. And I'm also going to clean up the outputs here, and I'm going to commit the changes to the notebook as well. So that was an A. There we go. And now this is create. Oh, wait a second, I'm forgetting the catalog. All right, so now commit create data processing pipeline. All right. So now what's left here is trying out Kedro Viz. So I'm going to go ahead and pip install it. So if I pip install Kedro Viz here, I don't need to add that to the requirements because my pipeline does not require Kedro Viz to run. So I'm just going to install it directly in there. And Kedro Viz is a web application, so it ships with a number of dependencies. You see here that it uses Fast API and Plotly for some of the plots, and it has some models as well, so it needs SQL Alchemy. But don't be afraid of all this. I'm going to launch Kedro Viz now, and I should have a new connection in a moment. I think I can ignore those. Yes, this is a bug that we have, we're tracking, but I can now open my browser, and this is the Kedro Viz interface. So as you can see here, these two on top represent my two input datasets. So one is the categories, and you can see here things like the the name, the type, and the file path, and so on. Then this box with the F here represents a node, and I can actually show the code over here just in case I want to have a quick look. And it also says where the node is defined and how to run specifically only that node. Then I have an intermediate data set that, if you remember, is going to use the memory data set. So it's not going to be persisted to disk. I have another node, and I have my final data set here. So you can explore around this interface. If you haven't been following along, you can see the demo. So if you go to demo.kedro.org, I'm going to share this in the chat. You can see a more complex pipeline. This uses our beloved space flights data sets that we use for our tutorials and parts of our documentation. And as you can see here, it's more complex because there are more data sources and more nodes and so on. And you can also see some of the more advanced features of Kedro Viz, for example, how you can parameterize the nodes and the pipelines, and you can see those here, and so on and so forth. So one more thing that I'm going to show you before we finish is how we can produce our own artifacts so that we can see them here in Kedro Viz. So I'm going to close the demo interface for a moment. And we're going to create some visualization for this data frame. So in particular, we're going to focus a little bit. Let's display the head here. We're going to focus on what were the repair reasons, or rather the problems that were found. And we're going to very quickly just do a simple word cloud to see how would that look like. And for that, I'm going to focus only on the events that I know are going to be written in English. So I'm going to filter those whose country is GBR. And now this would be GBR events. There we go. You see that we have here GBR events, 23,000 rows. And I'm going to very quickly copy paste some code that I have prepared to create a word cloud. So I'm using a package called word cloud that I was pre-installing before. And I'm going to go ahead to the repair, to the workshop steps. And I'm going to show you how this looks like in the end. So I'm going to create a word cloud like this. There we go. First of all, I'm going to filter some warnings because otherwise this is going to be very noisy. So warnings, simple filter, ignore. And then I'm going to create a word cloud. I will also need from word cloud import word cloud as well as stop words. And then I will use my GBR events that I created before. Sorry, this should be the problems. GBR is only the output of the problem. So I'm going to just copy paste that. There we go. Not EOL, but GBR events. So let's see how this looks like. There we go. So we have my list of sentences, and there's a variety of things here, like needs reboot, and needs longer lead, and so on. I'm just double checking that I don't need more filtering here. Yes, I do. I was missing something. So this is going to be filter that and that. Please give me some space. So this would be filter that condition and that condition. There we go. Only the drop, the problem column, and I'm going to drop the nulls. There we go. Okay. And I'm going to show only the first one for clarity. And now I'm going to use this problems GBR over here to create that word cloud. I need to import matplotlib as MPL as well. What else do I need? MPL. MPL.pyplot doesn't exist. There we go. Okay, so this is how my word cloud looks like. And I can see all the usual suspects like working, stopped working, unable, and then other things like related to the power supply and so on. So this could be a nice visualization that we could use. And so the idea is that doing that here in the notebook is nice, but if we are certain that we're going to run this several times, then we can as well create this as one more data set in our Kedro catalog and create some code that creates that. So I'm going to go ahead and keep adding things here in the catalog. So I'm going to add another data set that is going to be called word cloud plot. And the type of that is going to be a matplotlib writer. So matplotlib, let me check that I'm doing that right. So if I'm going to Kedro datasets, matplotlib writer, there we go. So that's the dataset that I'm going to use. Matplotlib writer. And then the file path is going to be, again, a new directory in my data. So I'm going to call this 09 reporting or tracking or whatever you want to call it. And then word cloud.png. Okay, so this is a new data set that I'm just going to use for output. And after that, I'm going to proceed and define a new pipeline that is going to take care of producing that plot. Pascal needs to go. All right, thank you very much. Remember that this is getting recorded, so no worries. I'm going to temporarily interrupt Kedro Viz. And I'm going to create a new pipeline called data science. Kedro pipeline create data science. Instead of putting that in the same data processing, I'm going to create a separate pipeline that is going to take care of that. And then this node is going to take my clean data frame as input and produce the matplotlib plot as output. So I'm going to call this plot word cloud. This is going to take polars as PL. It's going to take my DF, which is going to be a polars data frame. And from matplotlib plot figure import figure, and this is going to return, again, this is just for internal purposes, a matplotlib figure. So for this, I would need to copy paste parts of this code. So one thing is creating my list of problems that is going to come from the data frame itself. So I'm filtering those in the Great Britain and those that had a repair status of end of life. And then I am using this to create the figure. So I'm going to put just that. At the end, I'm going to return the figure itself. And I think I have a couple of missing imports here. So one is import matplotlib as MPL, and another one is matplotlib pyplot as PLT. And unless I'm missing something, that should be it. So that's for the nodes of the data science pipeline. And then I need to define the pipeline itself. So I will need to do from nodes import plot word clouds. And so my only node will be a node with the function being the plot word cloud. The inputs are going to be my open repair 03, which is the clean data set, if you remember. My output is going to be the name of my new data set, which is word cloud dash plot. So let me go there, word cloud plot. And then the name of the node would be plot word cloud node. All right, so if I did everything correctly, I can run only the pipeline that is called data science. Fingers crossed. Oh, word cloud is not defined. Sorry, I will need to from word cloud import word cloud as well as stop words. Let's try that again. Some warnings coming out, but all the rest is there. And now I should be able to see in data a new directory 09 reporting and my word cloud appearing here. So hopefully now Kedro Viz, if I restart it again, is going to be able to show it in my pipeline. Again, we have to ignore these temporary connection errors. Now I'm going to open that again. And you see that word cloud plot appears right there at the end of my pipeline. So Kedro Viz is also going to help me quickly visualize my outputs in case I need that. This session is not going to be more about Kedro Viz, but there's much more to it. So, for example, you can have a look at the experiment tracking interface that gives you some lightweight experiment tracking features. For example, you can compare several experiments and perform some plots and so on. You can find some more information in our documentation. And you're also able to define several layers to this pipeline and etc. So there are many more possibilities, but I hope this was good as an introduction. So I'm going to cancel that here, and I'm going to add my changes. So I made some changes to the catalog, and I added another pipeline, which was data science with its tests. And that is it, because I need to add the changes from the notebook. So now add data science, scare quotes, pipeline. Whoops. And that's it. So that is it. For now, I'm going to stop one more time and to see if there are any final questions before we leave. So now it's your time. Remember, we have other members of the Kedro engineering team here, so if you want to ask something about the project, that's your chance. Otherwise, I'm going to go back to the presentation for some final remarks. So let me go here and continue presenting. So that is it for this introduction. I really hope that you found it valuable. We are conducting, sorry, let me go there again. So the team, and especially my colleague Joe Stitchbury, is conducting very soon some user research on our Kedro documentation. And your perspective as Kedro beginners is really important for us. So if you want to participate and give your thoughts and so on, we're going to be reaching out to people on our Slack organization very soon. Or otherwise, you can reach out to us directly via email if you prefer. So that's it from our side. I encourage you to join our Slack workspace. I shared with you the links over there. We'll be sending a follow-up email, and so you have some of the links that were shared here in this chat, as well as some extra information and so on. And without further ado, I'm going to leave it here. And thank you all for your attention. So that is it from my side. And I hope, again, that you enjoy the workshop. We're going to do more of this, more advanced and with more use cases and so on. And we're also going to upload this to our YouTube channel. So if you go to Kedro-Python, you will be able to get a notification when we do any of this. So thank you very much again, and have a fantastic rest of your day.